So good morning all of you. Today we'll be seeing some basic concepts of communication and what is amplitude modulation given in your third module of your syllabus. Okay. So let's begin with the basics of communication. By communication or by analog communication, what we mean is that we are transmitting a analog signal. Analog signal is something that varies continuously with time. Okay, discrete functions or discrete signals are those signals that do not have every value at every point of time. So what it means is that we have a function of time that we are going to transmit this function of time through a particular channel so that it is generated at one point, transmitted and received at another point and decoded as per the received signal. This is the basics of analog communication. Okay. So in this particular session, what we'll be seeing is that we'll be studying what is amplitude modulation, the equation for amplitude modulation, the spectrum analysis for an amplitude modulated signal, and double sideband suppressed carrier and single sideband systems. Okay, so write down the definition of amplitude modulation. Amplitude modulation means you are changing the amplitude of a carrier signal with respect to its message signal. So in any kind of communication, we have two signals. One is called as the message signal or the modulating signal, modulating voltage. The other signal is called as the carrier signal. We have two types of signals. First one is the signal which is containing the information. The other one is the signal that is going to carry the information. You can compare this with your regular kind of postal communication. You have a letter and you have a cover, right? The cover is the carrier signal and the letter is the modulating signal. What you are supposed to do, you are supposed to put the letter inside the cover so that the cover can be transmitted. So you are transmitting the cover with the letter. The letter is the message signal and the cover is the carrier signal. Is that okay? You can take this as an analogy for your amplitude or any kind of modulation. You have a cover, you have a message. The cover is the carrier signal and the message is the signal. So this carrier signal should contain this message. The message should be incorporated inside the carrier signal. How we are going to incorporate the carrier signal message? You are going to change the amplitude of the signal, amplitude of the carrier signal with respect to its message signal. You have the information only in the modulating voltage and you have to send the carrier voltage. What you are going to do? You are going to change the carrier voltage in accordance with the contents of the message signal. What is that feature that you are going to change? You are going to change the amplitude. What is meant by amplitude? If this, I'll show you what is that. Let us consider a signal V is equal to A sine 2 pi t or something like that. So graphically you can represent this to be like this, something like this. Okay. Now this is the voltage signal and this is the time. I told you that it is a function of time, right? So here this is called as the amplitude, the maximum value of the voltage that can get a maximum or minimum. This is called the amplitude. So you are changing the amplitude of the carrier signal with respect to the message signal for transmission. Okay. So the carrier signal looks like the cover in a postal communication, and the message signal is what is put inside. So here what you are doing, you are putting this message signal inside the carrier signal so that the message is being carried by the carrier signal. So how do you define amplitude modulation? Amplitude modulation is a type of modulation where there is a carrier signal and this carrier signal's amplitude is varied with respect to the message signal. Understood all of you? So let us consider the carrier signal voltage. Vc is equal to Vc sine omega ct. Omega c is the angular frequency. Now let us study all what we have studied theoretically in a mathematical equation format. So we have two signals, one carrier voltage Vc, the small letter always in electronics throughout, small letter represents the instantaneous values of the voltages and capital letter represents the absolute values. Instantaneous values means those values which are not permanent, which changes according to time. Okay, is a function of time. So this Vc changes with time. So you call it as, you have noted it down to be a small Vc. This capital Vc is an amplitude, is a maximum value of the signal. So we call it as capital Vc. Okay. Similarly, we have another message signal. This message signal can be anything, it can be any kind of signal. Initially, amplitude modulation, we were considering only voice signals to be transmitted. So in most cases, we will be studying about voice transmission only. Okay. Here Vm stands for the modulating voltage. Vm, instantaneous modulation voltage at every point of time, is given by the mathematical equation Vm sine omega m t. Okay. Here this Vm sine omega t is not the exact way with which we do practical examples. Here, for the sake of our study, we are considering the message signal to be a sinusoidal wave. Suppose I am talking, I do not know at what range or what is the equation with which I can talk. The signal need not be synchronous, or signal need not have any proper systematic equation. But for our sake of study, we will be using sinusoidal or cos signals for our analysis purpose. You have two signals, carrier and modulating. So let us understand in detail about how this signal is being modulated. Is it legible here? So let us consider a message signal moving in this fashion. As I told you, message signals are unpredictable, can take any form. Okay, it need not be like this. There's no conditions for that. It could be anything. So let us consider this to be the message signal, and the carrier signal is something that we are generating. How do we generate signals? Using oscillators, right? Crystal oscillator or some kind of oscillators we use, and we generate an ordinary sinusoidal wave with a good power. This carrier signal acts as the cover. As I told you before, the carrier signal acts as the cover. The message signal is the information containing signal, right? So the cover is something that is empty, that we are creating according to our convenience. We can create high power signals, we can create however we like, we can create. We are creating this, and why we are modulating, I told you in the previous sessions, because the signal should have enough capability to be transmitted to a longer distance. That is the reason you need to modulate it, right? So while you modulate it, what happens? You need to increase the parameters. So this is how you get the output amplitude modulated signal, where you are mixing both the message signal and the carrier signal. And here I have shown you a graphical representation of AM as well as FM. In frequency modulation, what we are doing is that We are changing the frequency of the carrier signal with respect to the message signal and not the amplitude. In amplitude modulated signals, we are changing the amplitude of the carrier signal with respect to its message signal. But in frequency modulated signals, we are going to change the frequency of the carrier signal with respect to its message signal. Okay? So the next very important concept that we are going to study is about frequency spectrum of an amplitude modulated wave. Can anybody tell me what is meant by frequency or what are the frequency components available? We have seen two signals, right? The first one, VC, is equal to VC sine omega c t, right? What is the frequency component in this? Omega c. Omega c is the angular frequency. What is angular frequency? What is frequency and what is angular frequency? Very simple. Angular means in terms of circle, right? Right? What is the circle? Maximum radiance, 2 pi. So, omega c is equal to 2 pi fc, where fc is the carrier frequency. Right? So, one frequency component is the frequency component of the carrier signal. Naturally, what would be the other frequency component? What is the other frequency component? One frequency component is the carrier signal. What is the other signal you have? What are the two things you have? One is the cover and the other one is the message. For the cover, I told you. What is the next one? For the message. Message signal, what happens? Omega m is equal to 2 pi fm, right? So you have two frequency components, and we'll see how to find out the frequency components in an amplitude modulated signal. The frequency components present in the amplitude waves are the carrier frequency and the first pair of sideband frequencies. That means that sideband frequencies are there. We have two things, Fc plus Fm and Fc minus Fm. You have two carrier frequency components, sidebands. We have two sidebands. First sideband is called as either it is Fc plus Fm or Fc minus Fm. So if you take these two components, what it will be? One will be Fc plus Fm, the other one will be Fc minus Fm. So now let us draw the frequency components in a graph where the y-axis is the amplitude and the x-axis is the frequency. So graphical representation of frequency sidebands. Next is a very important definition. What is meant by modulation index? Now when you do something, whatever you do, you need to have a calculation of to what extent you have done. Suppose you have modulated a signal, you should be able to understand to what extent you have modulated. That is called as modulation index. Modulation index is the amount of to what extent is the signal getting modulated. While a modulating carrier signal A carrier signal is varied by its instantaneous value. So modulation index will be the range of its variation. How far has the carrier signal been modulated with respect to the message signal? So definition for modulation index. Modulation index is the ratio of the message signal to the carrier signal amplitudes. Okay. So graphically represented like this. Details about more details about modulation index and the continuing sessions we'll be seeing in detail about what we understand by modulating a signal and what is that modulation index and so on. Thank you all. Thank you for listening to me. Thank you very much.